Alright, so doing example 2 here, we have to recall our rules. If you recall from our rules, what we can do is that cube root actually can go through to every single item. So it's the cube root of 16, the cube root of x cubed, the cube root of y to the 8th, the cube root of z to the 4th. It goes through to everything. And if you remember from some more of our rules, we can rewrite each of those. I can split this up, let's worry about separating this, into the cube root of 8 and the cube root of 2. And the reason why I can do that is 8 times 2 is 16, right? 8 times 2 is 16. And the cube root of 8. Can someone think of 3 numbers that multiply together to give you 8? Well, 2, right? So this we rewrite as a fraction. And this is the 1/3 power. So 3 over 3, okay, because it's 3 times 1/3, which will be 3 over 3. And this we can rewrite as y to the 8 over 3, because when we rewrite roots as fractions, right, basically all you're doing is putting whatever this is in the denominator, and whatever the exponent is underneath is the numerator. So then this would be z to the 4/3. So now when we start simplifying here a little more, as we just said, the cube root of 8, that's 2. Because 2 times 2 times 2 is 8. The cube root of 2, can you think of can you think of 3 numbers that multiply together to give you 2? No. Okay, so that is as simplified as you can make it. And that is 2 to the 1/3 when we rewrite that. X to the 3 over 3. Well, what is 3 divided by 3? That's 1. So that simplifies. Now, here's another problem that we run into. You cannot have improper fractions in your exponents. You just can't do it. Not allowed. We have 8/3 there. You can't have 8/3. So I need to simplify y to the 8/3. So here's what we're going to do. I'm going to rewrite that as y to the 3 over 3 because I'm trying to find wholes. Okay, so let's figure out how I can make wholes out of that. I can write it as another 3 over 3, and I can rewrite it as y to the 2 over 3. And here's why. I just grouped everything in terms of wholes. Here's 3 of them, here's 3 of them, and here's 2 of them. 3 plus 3 plus 2 is 8. All I did was group it according to the denominator. So the reason I did that is now we can see what simplifies and see what our remainder is. What's left over? 3 over 3 will give us 1. 3 over 3 there will give us 1. And I can't do anything else with that. That is okay. The reason why this 2/3 is okay is because it's not improper, and you can have fractions in exponents. Okay, it's just this is not improper, so it's okay. And I'm going to do the same here with this z. So I'm going to put this into groups of 3. So this will be z to the 3 over 3, and how much is left over? 1/3 is left over. 1/3 is left over. So I'm going to keep simplifying here. I get a 2. Keep simplifying. 2 to the 3rd. I get an x. Okay. This is y to the 3 over 3. So that simplifies. 3 divided by 3 is just y. This is 3 over 3. That simplifies to y. This is 2 over 3. Can't simplify it anymore. 2 over 3. This is 3 over 3. That simplifies to 1. And this can't simplify it anymore. So here's what I'm going to do. I'm going to put all of the non-fractional exponents together and all of the fractional exponents together. So I have a 2, an x, a y, a z, and I have a 2 to the 1/3, a y to the 2/3, and a z to the 1/3. All I did was put all of the non-fractions together and all the fraction ones together. So these combine any like terms. That's y squared. This right here I can rewrite as the cube root of 2. This I can rewrite as the cube root of y squared. This I can rewrite as the cube root of z. All I did was change them back into roots. So the cube root, and notice Now, whatever's in the bottom, that's the root, right? So the cube root of 2 to the first power, that's the 1. The cube root of y to the second power, because that's what the numerator is. The cube root of z to the first power, because that's what the numerator is. So when I combine those all together, I just put everything under one giant cube root. So we get the cube root of 2y squared z. On the outside I have a 2, an x, a y squared, a z, and the cube root of 2y squared z. And that is finally your final answer, simplified. I know, a lot. Some of these will be